Hi everybody, it's Ms. Dupree. In today's lesson, we're going to talk about energy transfers and transformations. We've already learned that energy is what makes matter move or change. We also say that energy is the ability to do work, which is when a force makes an object move. We have learned that energy can take many different forms. All energy can be either potential energy, which is stored energy waiting to be used, or it can be kinetic energy, which is the energy of objects in motion. Some examples of potential energy are chemical energy, which is stored inside of things like food or batteries, and it's just waiting to be used. Other examples of chemical energy are gasoline for your car or firewood to make a campfire. Chemical energy gets burned to release the energy, and that is called a fuel, anything that gets burned for energy. Nuclear energy is the energy that is inside of atoms, and the atoms can get split apart and they release huge amounts of energy. That's how nuclear power plants work, and unfortunately, that's how nuclear bombs work. Gravitational potential energy is the energy that something has because it's above the ground, and gravity is pulling on it, wanting it to fall back to the ground. And elastic potential energy is energy that happens when you stretch or squeeze something like a rubber band or a spring toy, and the object is pulling or pushing to get back to its normal position. Some forms of kinetic energy are motion energy, which is any object in motion, from cars to animals to the blowing wind outside. Light energy, which is also called radiant energy, can move across empty space until it reaches your eyes. And that's how the sunlight reaches Earth, moving through space. Heat energy, which is also called thermal energy, is the movement of molecules. And we have already learned that the more heat energy that objects have, the faster the molecules move. Electric energy is the energy that moves through wires to power things like refrigerators or TVs. And sound energy is the energy of vibrations that move through the air until they reach your ears. But energy doesn't just stay in one place or in one form. It moves all around our world, and it can change from one form to another form while it's doing that. So I want to introduce something called the law of conservation of energy. This scientific law says that energy does not get created and it does not get destroyed. Now sometimes, like if your cell phone's dead, you might want to say, oh, it ran out of energy. But the energy didn't disappear. It just changed form, or it went somewhere else. And then when you charge your cell phone back up, you're not creating brand new energy. You just use electrical energy and change it into chemical energy for the battery. So the law of conservation of energy says that energy does not get created and it does not get destroyed. It's just doing one of two things. It is either moving from one place to another place, or it is changing from one form to another form. But the energy is still there, and that's a very important thing that you need to understand. So an energy transfer is the movement of energy from one place to another, or from one object to another. The form of energy does not change. For example, if you touch a hot pot and you burn your hand, it's because the heat energy moved out of the pot and into your hand, but you still have heat energy. That's a transfer. The heat just moved from one place to another place. Or these turbines work because the wind that's blowing makes the turbine spin. The motion energy that was in the wind has been transferred to the turbine. So now the turbine is moving. This is a transfer because you still have motion energy. It's just in another object now. An energy transformation is the change of energy from one form to another form. Think of the Transformers movie. Optimus Prime can change from a robot into a truck, from a truck back into the robot. No matter which form that he takes, he's still Optimus Prime. Only the form is changed. Energy is the same. It can transform, or change form. So for example, we can use solar panels to capture sunlight and change it into electrical energy. And that's a transformation from light into electricity. But we still have energy. Or we could use this propane gas on the grill. So the propane is chemical energy, but we can use it to power up the grill to make heat energy. That's also a transformation. The chemical energy has not disappeared. It has just changed form into heat energy. So we have lots of energy sources in our world, but in order to use them, we usually have to make an energy transformation. This can be super simple, such as burning firewood to make light and heat energy. That's an energy transformation from the chemical energy inside the wood into heat and light energy. But for many, many other things in our world, we use electricity. And unfortunately, you can't just walk around and collect energy out of the water or just pull it straight out of the air. It doesn't work like that. It has to be changed into electricity first. So we're going to take a look at a coal burning power plant. This is how, not Costa Rica. Costa Rica is really good about using green energy. But many other places around the world use coal, a fossil fuel, to make electricity. But the thing is that it takes a lot of steps to make this happen. First, you have to have coal. Coal is chemical energy. Remember, fossil fuel, coal is a fossil fuel, and fossil fuels are the remains of organisms that lived hundreds of millions of years ago, and they died with that energy still inside them. So in order to get the energy out of the coal, coal is a fuel. So in order to get the energy out, you have to burn it. And when you burn the coal, it transforms from chemical energy into heat energy. So now the coal is burning, and the fire is used to heat water, which is inside of these pipes. That's a transfer. The heat energy moved from the fire into the water, but it's still heat energy, so it's a transfer. As the water heats up, it turns into steam, and it's going to start moving through the pipes. So that's going to be a transformation from heat energy into motion energy, because now you've got the steam that's moving. The steam moves through the pipes and into the turbine, and that's going to make the turbine spin, and that's going to be a transfer. The motion energy is moving from the steam into the spinning turbine. So that's a transfer of motion energy. And now the spinning turbine is going to make the generator also spin, which is another transfer of motion energy from the turbine into the generator. Now, when the generator spins, it starts making electricity. And it uses a tool called the transformer. So look at that word. It's called a transformer because there's a transformation from the motion energy of the spinning generator into electrical energy. And then the electricity moves through wires until it reaches your house at some point. And that's going to be the transfer of energy from the power plant to your house. It's a transfer of electrical energy. And that's how coal makes electricity. So you can see that in order to make electricity out of coal, it takes many steps, both energy transfers and energy transformations. So if we look at just the transformations, just the change of form of energy, you'll see that in order to make electricity, you have to make 4 energy transformations. We start with chemical energy in the coal, to heat energy in the fire, to motion energy in the steam and the turbine and the generator, and finally to electricity. But according to our law of conservation of energy, no new energy was created and no new energy was destroyed. It just changed form. All right, guys, that's it for this lesson. Make sure that you understand that there are different forms of energy and that you can identify them, and that you understand how energy can be transferred or transformed, but energy does not get created or destroyed. If you have any questions, please ask. Otherwise, you're all set. Good job, everybody. See you next time.